that's fine. Hi, everyone. My name is Ethan Jimenez from Microsoft Edge Web Platform team, and I'm here today to talk about a little bit of the status of Masonry and the discussions that are going around the design. So without further ado, let's dive right into it. With a very simple question: what's going around with Masonry? Before we get into more about the conversation that's going around the design, let's talk a little bit more and get a shared understanding of what Masonry is. Masonry layout, it's basically a layout that allows web authors to present flowing content in multiple columns or rows, depending on whether we want another or horizontal reading flow, from the start of the container, flowing or moving into the end of the container. Masonry is deliberately similar to grid layout since we have two-dimensional flow of its contents. However, Masonry is only interested in aligning items within an axis, which is called the grid axis. In this case, highlighted by the green lines, well, are the vertical lines. And the horizontal pink lines are the rows that currently in green layout would align the contents in the block axis. However, for Masonry, those pink lines are not desirable since we want the items to be packed to the top of the container. Since we expect those items to be stacked following each other, we call that the stacking axis. Masonry has also been compared to multi-column layout since we want the content to be flowing within a set of columns, a set of defined columns. However, the principle of Masonry is again packing the contents to the top. So multi-column layout does not follow this layout since it fills the available block size, and when we overflow a column, the contents will be passed into the next one, which is really not what is going on right here. In the image on the screen, you can look at the Masonry way of flowing items. It will choose the column that has the content on the top or closer to the top. So for sure, the layout is pretty close to what Pinterest is doing, the layout from Pinterest. And there are a lot of people online that wants to replicate this design. You just have to type Pinterest layout tutorial in Google and you will find a lot of results, some of them exemplified here. So here's the key to what I want to cover in this talk, and it is pretty much all the discussion that is going on around Masonry. And since we are talking about two-dimensional flow of contents that are defined and columns being defined, Masonry, it's being called that it should be an extension of grid layout, like basically an extension of the functionality from grid. The answer to that is kind of complicated. Our team has been studying how Masonry could be integrated into the grid module right now and the complexities that will be involved with that transition. And a prevalent topic that is being brought up is that Masonry is, well, we brought it up to the table, is that Masonry is so fundamentally different in some aspects from grid that it will require a lot of exceptions and new algorithms being introduced to the module that we probably want to keep it as a separate thing, like its own display type. Originally, we wanted Masonry to be kind of simplified from grid vocabulary and definitions to avoid a lot of the complexity pitfalls that we fall into when we implemented subgrid and some other optimizations. So the alternate approach was created. However, many articles have been published by WebKit and Chrome teams to debate whether the behavior of Masonry should land within the grid specification, or if Masonry is different enough, then web authors might find easier to learn a completely different display type. Make Masonry like a new thing. WebKit representatives brought up that developers expected some of the capacities of grid within the grid axis to make the definitions for the tracks. And losing this capacity will be undesirable. The CSS working group decided to combine the ideas of integrating Masonry into grid or making a new display type into a combined spec that it's what's currently published. And the capabilities of grid are considered within this combined spec to the moment. So two syntax were created to address like these two different approach. One, where Masonry is integrated into a grid layout. So in this approach, the display it's kept purposefully as grid, and we will change the definition of one of the axes. In this case, since we want like the rows to be the stacking axis, we'll be defining them as masonry. The second approach and the second syntax is grid independent, and we'll make a new display type masonry. In this approach, we assume that we have like a single grid axis, so we don't have like two definitions of grid template columns or grid template rows. We just have one that we can define whether it is flowing in columns or in rows using the masonry direction. There's a couple of other properties that we can use to define whether we want to flow from right to left, from bottom to top, etc., etc. So here's the nitty-gritty of the talk. Some believe that the differences in these two approaches are purely syntactical. The conversation has been dragged into questioning whether masonry is essentially a grid or not, questioning if what is a grid, like basically the question what is a grid, and if we could reduce masonry to basically be called a columnar grid. However, we believe that the results of using masonry, as currently defined in both of the approaches, could result in some unexpected behaviors. And even some of scenarios with masonry would be simplified by using a new display type. And we can argue whether that is desirable or not for authors. Some of these scenarios I will bring up later in the talk. So let's dive right into some of the specifics of how masonry works. And in summary, we could say that masonry basically works the same as grid, except for basically everything. Placement is different, sizing is different, layout is different, and subgrid also works a little bit different from there. So let's start by defining how masonry chooses to place the items. Inheriting from grid layout, we have the ability to place items on explicit tracks. This is like the happy path for how inheriting some of the specification from grid works perfectly. But the interesting part comes when we treat with auto-placing items, since masonry defines its own placement algorithm, which essentially keeps the items closest to the top, like I mentioned already. In this example right here, we have been placing items that are numbered for order purposes, 1, 2, 3, 4. And in the masonry world, we would choose the next available space closest to the top. So intuitively, we will assume that it will be on the leftmost track. We will put the 5. But in the masonry world, we want to choose the one that is closest to the top. So we will be putting the next item below the 4, which is the closest one. And if we choose to put another item, it will be placed below the 2 in that position. So this is a little bit, takes a little bit a while to understand how that works, but it's fairly different from grid, which assumes like it's always flowing from the next column, the next row. This makes grid placement effectively different from masonry's. And it is important to discuss whether it should be expected that changing the definition of the row axis from none to masonry, in this example that I'm putting right here, should affect the columns. Authors need to understand that they're by changing the row definition, they're making the container a masonry, and as such, they will be using a different placement algorithm. If they use a different display type, however, this expectation is very explicit. You are changing the distribution of things. And an author will effectively decide whether they like the container to be a grid or a masonry. A big note here, this issue with the items being visually reordered is like a key discussion topic within the working group. And an author might opt out of this behavior, this weird behavior of kind of like mixing the position of them. There's a property called masonry slack with authors being able to like specify that you want to keep the behavior of going left to right, top to bottom. Now, moving into another key part of how grid works, I did a whole another presentation on why placement and the sizing algorithms are very particular in the order that they should happen. And breaking this notion that the placement should happen before sizing was like a key important part of grid. And it breaks a lot of things if you don't follow that very closely. However, Masonry made us revisit this problem since there's a very unfortunate interaction with how we need to compute the placement. In order to determine the shortest column of a masonry, one needs to perform layout of items. Like you need to put them and lay them out to know what's the next position on that track. So that implies that you need the container block of an item. And the containing block of an item needs the grid area of the item to determine the available size. So tell me if you heard this one before. Mason replacement algorithm relies on the track sizes that it is spanning. But the sizing algorithm, it's very reliant on what tracks you put the item. So this kind of like basically implies a circular dependency where if you choose one placement, you get one sizing. But if you alter the sizing, then placement might change. So this was very particular with subread, and we probably don't want to repeat that again. The CSS working group broke this cycle by introducing this cute little sentence that says all items with an automatic position will basically be assumed to be placed everywhere, regardless of whether they are ultimately placed in that track. This effectively means that the items that are placed will contribute to all of the tracks. You will assume that instead of like figuring out the placement and then do sizing, just assume that they're everywhere and do sizing that way. So let's pop the champagne. Masonry is done. Masonry is easy, but it's not that easy. We have like a series of implications right there. So let's not get ahead of ourselves. I won't go into details of how this is troublesome from implementers, but we will focus on a user-facing side effect of this, that the spec is very clear on the implications from placing items on every track. On this paragraph, they basically said that the intrinsic tracks, when you decide to make them auto, they will be assumed to take every item that you put on the container. So that might have the side effect that a track might be larger than any item that it's accommodated within that track. In this example, well, in this one, we have like just a single 100 pixels item that since it's auto, the masonry track is set as auto. We don't have the placement beforehand. So we will assume that every track in this definition that we have like a container that has 3 auto tracks should take space to accommodate that item, all of them. So it will be sized to 100 and 100, 100 pixels. So even if we have an item with 50 pixels being accommodated in one of those tracks, that track, it's not going to be fit for that item. It's going to be 100 pixels so that every item can be accommodated there. This has the other side effect that even tracks that don't end up having items are going to be sized to that 100 pixels. So this means that authors switching the row definitions from the default value of a grid layout from none to masonry might question themselves, why did my grid columns blew up in size? Like initially I had this very tight container that all of the items that were 50 pixels are very tight within their track. And now they have like some extra space that I don't know where this came from. And even worse, if these items have like a stretching behavior on the columns, it might even cause some reordering, because when you size them to a bigger column size, it might be able to be a little bit shorter on the block size. And this resurfaces the issue of the placement. So not only you change the size of the columns, you effectively change how they are looking in the final container. So we argue that an author needs to intentionally switch to a different kind of sizing. This might be the change. This might be a result of changing the display types, and you should be very aware of it. But there's a silver lining in all of this issue with the all tracks basically accommodating all items, and is that in grid we were not able to define an intrinsic repeater, since figuring out the size of an intrinsic track relying on having placement determined at that moment. So you have to remember that we actually broke that cycle with Masonry. This is another key difference with grid, where if we want to make another repeater fill the available space, like in this example, we have a container that has 300 pixels. We could not define these grid template columns autofill auto, because we would need to know what items are going to be placed there. Instead, what we would do is to define like a minimum or maximum size, change the definition here so that you specify we have an auto size, but if you don't know how to figure that out, use 100 pixels. And so we would define the tracks here to be 100, 100, 100. In Masonry, this is not the case. The specification for both of for only the display type Masonry defines that we can use a new heuristic where we basically, since we are accommodating every item everywhere, well, just take the largest contribution of all the items and use that to figure out the auto size. So in this case, we could do autofill and just assume from the size of the items. In this case, we have 50, 100, and 75 pixels. Just take the largest one and use that as the baseline for auto tracks. So you can compute the autofill to be 3 repetitions of 100. This unlocks an exciting possibility of a new initial value for Masonry. And the spec introduces the auto areas repeater, which is the new default exclusively for the display type Masonry. This is not available in grid, in layout grid as of this moment. If there are, this auto repeater specifies that if you have auto areas, named areas defined in your container, you will just like grow the size of the repeater to accommodate those name areas. And otherwise, if you don't have them, like an example about, you will use the behavior out of it that will basically grow in size up to take the available space. So this new definition for the intrinsic repeaters, as I said, is exclusive to Masonry layout right now. So thinking of the most common case of just having like a single container, let's say again, we have like 300 pixels available, but we just do display type grid and say the rows of this grid are going to be Masonry, and we start pushing items to this grid, we will have this grid being the result. So no automatic tracks are going to be computed, and as such, we will just put one item after another, which is probably not an ideal initial value for Masonry when we can have an auto areas being defined and say, just fill out the 300 pixels with, the largest available item, just use that value to compute 3 different tracks, and you can push them out in whatever order you want, which is very intentional, again, if you just do display type Masonry, and you don't even have to compute anything else. This is like the most common case, just using display Masonry right out of the box. And don't even get me started with subgrid. Subgrid has been like a pain to implement because of a lot of reasons, but there has been some exceptions to how subgrids are going to behave when you mix in Masonries in between. The auto-placed subgrids don't inherit line names specifically because since you cannot figure out placement, you cannot be explicit about what line names are you inheriting, since every item has to be placed everywhere. Another one is that the placement gets complicated real fast when you're starting nesting a lot of Masonries and sub-items. This is another topic that could sparkle a lot of discussion on how auto placement, it's going to be super tricky to get with multiple levels of subgrids. So our conclusion is that it's more than just syntax that we need to define within the Masonry discussion. Like, there are clearly some scenarios that are going to be affected by how behavior is defined, and we make the case that these are important conversations to have, not just like trying to get if Masonry is a columnar grid, what is a grid? We have to think about more, what are the use cases that are important for authors, and try to drive the conversation around that. So there's some feedback that we need from you guys. If you want to collaborate, if you're interested in Masonry and how the shape of that layout is going to be like, read the combined spec, read the blog post that everybody is talking about like the definitions of the syntax. And in order to make sure that we get that right, you can comment your feedback, any kind of comments, use cases into the following working issue. We're taking a lot of feedback to know what to do next. And just give a thumbs up, well, a +1 on the implementation bug from Masonry. So a special thanks to all of my partners in Google and Microsoft that has done a lot of work to understand Masonry and where are we going with this. Thank you. That's basically it. And any questions? I guess not.
All right, sounds like people are ready to get out of here.
Yeah,
Thank you, Ethan.
for sure.